So let me start out by stepping back and just talking a little bit about natural language processing. Artificial intelligence is suddenly really very a big topic again in the popular press. And it was so in the past, in the 60s and 80s of the last century, and then sort of drifted away and now is back. Its general goal is to let computers display intelligent behavior in the manner that humans do. And I don't want to go into what it means to display intelligent behavior now at a general level, but I just want to observe that human intelligent behavior almost always somehow relates to language use, because typically we communicate our intelligence through language. I'm not saying that intelligence is language use. I'm saying that is how we perceive human intelligence, typically, not exclusively. And that is why natural language processing is such an important subfield of artificial intelligence. It's the subfield of AI which deals with human language production, meaning which tries to get computers to produce human language and to understand human language, i.e., to be able to communicate with humans using natural languages such as English. And an important further field in computer science is machine learning, which typically nowadays I think is considered a sister subfield to artificial intelligence rather than a subfield of artificial intelligence. And machine learning is concerned with developing algorithms that allow computers to detect patterns in large amounts of data and to apply learned models and to make predictions. And the renewed interest in artificial intelligence currently comes mainly through the rapid development of new machine learning methods, namely neural computing. And the other aspect is it's not just that machine learning has improved, but as machine learning changes, we also need to sit down and think about how do we formulate the problems we are interested in from artificial intelligence in general, or NLP, natural language processing in particular. How do we formulate them for these new machine learning paradigms so that they can perform optimally? So natural language processing typically has inputs as inputs documents, and then there are applications such as summarization or translation into other languages, or finding named entities like person names or place names or company names, or categorization of documents. And these can be all sorts of categories, like documents can be categorized as being legal or not legal, or emails can be categorized or personal or professional. I'll be talking about that later. Or newspaper articles can be categorized as politics, arts, and sport. And the documents that serve as inputs to these algorithms can be either single large documents, which I'm trying to indicate with this one, or collection of documents, like a collection of emails, or all sorts of other notions of documents, in which he looked at the Enron Corpus. In fact, all of the studies here look at the Enron Corpus. So let me briefly summarize the Enron Corpus. Enron, as you may remember, was an energy trading company that got extremely large and then went spectacularly bankrupt in late 2001. The bankruptcy led to several federal legal proceedings, and as part of that, the federal government made public the email inboxes of 158 core employees of Enron, which collected emails from over 18 months. And this was exciting because studying email is clearly of great interest to us, because we all use email a lot, and it's a crucial part of how we communicate nowadays. But it is very hard to get at email data because of privacy concerns. So unless you work for Google or Microsoft and you have access to other people's emails that way, as an academic, we basically couldn't study email until Enron went bankrupt. The Enron Corpus includes correspondence with many more people than just 158 core people, but we have their complete inboxes over this 18 months span, in and out boxes. The correspondence is, as we expect, mainly professional in nature, but then see the fourth study I'll be talking about, and it's because it's professional, it's task oriented. People are trying to solve problems mainly. And we must bear in mind that this corpus reflects a particular communicative setting. It is a large American corporation. In fact, its set in Houston that may also narrow down the kind of generalizations we might want to make. And it's from the early 2000s. And a lot has changed in terms of communication and corporate culture since 2000. So we just need to bear that in mind. But since it's the first such large email corpus, we're going to use it. So in this first study, a proof study, we want to use a social network to predict power. And I'm going to explain the key point using a made-up email for simplicity from Mary to Bill saying, hey, I'll have dinner with Ken today. So traditionally, if we have a bunch of emails, what people do is they use the metadata to induce a network. The metadata is this part. It's the from and the to, and perhaps also the timestamp, which I'm leaving out here for simplicity. And you disregard the content of the email. And then you say that if Mary sends a message to Bill, then Mary and Bill are connected in the social network. And I will call that the email network for now. And then what our proof said is, well, let's not discard the content here. Let's not just look at the metadata. Let's look at the content of the email, but look for something very particular, namely people who are being mentioned in the email. And this particular email, Ken is being mentioned. So the idea here is that if Mary is sending an email to Bill and mentions Ken, then both Mary and Bill know Ken. And we can extend the social network that we're extracting from this single email beyond the email network to what I'm going to call the mention network, which has both Mary and Bill knowing Ken. We don't know whether Ken actually knows Bill. We probably suspect Ken knows Mary, but maybe he doesn't know her yet. Maybe he doesn't even know yet that he'll have dinner with her. So the minimal assumption we can make is that Mary and Bill know Ken. So how do we relate the social network to power? Here, we're going to do a very simple assumption, which we will see works extremely well, which is we look at the degree centrality. And the degree centrality simply means how many other nodes we're connected to. So if you think of this here as a social network, the blue dots are people, the green lines represent being connected. Person number 1 is connected to 4 people, so he or she is more connected, has a greater degree centrality than person 2, who's connected to 3 people, and people 4 and 3 are connected to 2 people each, and person 5 is connected to a single person. And then we simply say, well, we predict 1 has more power than 2, 3 and 4 are at the same level of power, and 5, being the least connected, has the least power. A very simple assumption that works extremely well. Here are our results. We first compare our metadata, our approach using the social network to a bag of words approach. Bag of words means we look at the body of the email and we just train. We have a training set and a test set. And on the training set, we just investigate what are the words that are predictive of power. We use some machine learning method. We learn which words predict power, and then we apply it to the unseen test set and make predictions, and that gives us the accuracy. And using this approach, which was pioneered by Gilbert in 2012 and is a very straightforward NLP technique, we get an accuracy around 82%. And then when we switch to using the email network only on the same data, we do much better already, 87%. So at this level, discarding the content of the email and instead looking at the metadata only performs better than simply looking at the words of the email. We now switch the evaluation corpus from small to big. We do that, we had to use a very small corpus because of the nature of this word-based study, but we want to do a study for all of the data. So we switch from small to big, we repeat our experiment, our numbers go down a little bit from 86. Sorry, I meant to be updating here. Our numbers go down from 87 to 85 on the larger corpus. This just tells us that the larger corpus is more difficult. But now we do the core of the experiment, which is we change from the email network, which comes from the metadata, to the mention network, which is based on the names mentioned in the body of the email. And we go up from 85% to 87%. A 2% increase at this level of performance is important and can make an important difference in the quality of tools. And then we expected that if we combine the two networks, we'll do even better. but in fact we didn't. We performed worse again. So the interesting thing is that the mention network is performed better as a social network underlying the power prediction than the email network itself, which is a standard way of doing things. So to summarize here, the email social network is a powerful tool for predicting power, and it beats using the words in the email. But the mention network, which is the innovation that Purv brought to the study, performs better. And the specific way that it was used can be summarized in the following slogan: "You are the boss if people get mentioned to you," which intuitively makes sense that your underlings will be reporting activities of other people to you and mention people to you left and right. Here's my overall conclusion then. The Enron Corpus is still, 20 years after its creation by its users, very useful for studying the effects of extra-linguistic factors in communication, and the extra-linguistic factors we have looked at are power and gender. There are very complex interactions in language use between power and gender and the social network the readers and writers form, and the type of communication they're exchanging, private or personal. And natural language processing should take the documents into account, which it always has, but we should also always look at the social network formed by the readers and writers as much as we can to improve our predictions and to see whether we can learn something about that social network from the documents.